Picture a mountain in northern Nevada. Inside it, geologists estimate, sits 4 million ounces of gold at $2,000 an ounce. That is $8 billion locked in stone. On paper, the owner is wealthier than most nations. In reality, he may be bankrupt. This is the central paradox of gold mining. Owning gold in the ground is nothing like owning gold in your hand. A gold coin can be sold in minutes at a bank in Zurich or a dealer in Mumbai. A gold deposit cannot be sold, spent, or even touched. It must first be found, measured, permitted, financed, dug, crushed, chemically stripped, and refined. A journey that can take 15 years and swallow billions of dollars before a single bar is poured. And even then, the mountain may never yield a profit. The gold is real, the wealth is not, at least not yet, because between the rock and the vault lies a gauntlet of costs so brutal that most gold discovered on Earth will never be mined at all. Consider that the average gold ore contains just 1 to 5 grams of metal per ton of rock. To extract a single wedding ring, roughly 20 tons of earth must be moved, hauled, ground to powder, and doused in cyanide. The gold is invisible to the naked eye, dispersed through stone like sugar dissolved in an ocean. This is why a deposit worth billions on a spreadsheet can be financially impossible to extract. The market value of the metal is only half the equation. The other half is the cost of freeing it, and that cost is often higher than the prize. Mining companies fail not because they run out of gold, but because they run out of money before the gold pays them back. Throughout this film, we will trace every dollar spent turning buried rock into bullion. The drilling gambles, the permit wars, the machines that cost as much as skyscrapers, the chemistry, the energy, the cleanup that outlives the mine itself. It begins with a single number, one that decides whether a mountain of gold is treasure or worthless dirt. That number is called ore grade, measured in grams of gold per ton of rock. It is the first thing any geologist calculates, and it governs everything that follows. A high-grade underground mine might carry 8 to 10 grams per ton. A large open-pit operation may survive on just 1 gram per ton, a single gram of gold hidden inside 1,000 kilograms of stone. To visualize 1 gram, it is smaller than a paperclip. Now bury it inside a rock the weight of a small car, and you begin to understand the problem. Gold deposits are not veins of glittering metal. They are vast volumes of ordinary-looking rock in which gold is scattered at microscopic concentrations, often invisible even under a microscope. This is why grade, not size, decides a mine's fate. Imagine 2 deposits. The first holds 10 million tons of rock at half a gram per ton. The second holds 2 million tons at 4 grams. On paper, the first sounds bigger. But the second contains more recoverable gold and costs a fraction to process, because you move 1/5 as much rock. A billion-dollar deposit at 0.3 grams per ton can be completely uneconomic, while a smaller, richer body turns a profit. There is a threshold called the cutoff grade, the minimum concentration at which mining pays for itself. Everything below that line stays in the ground forever, no matter how many total ounces it contains. Raise operating costs, and the cutoff rises. Suddenly, millions of ounces become worthless dirt. Drop the gold price, and the same thing happens overnight. This is the cruel arithmetic of the industry. The amount of gold you can mine is not fixed. It shrinks and swells with fuel prices, wages, and the market. A mountain holding $8 billion in metal may only contain a few $100 million that can be profitably reached, and often far less than the cost of reaching it. But before any of these numbers can even be calculated, someone must prove the gold is truly there. That proof does not come cheap. It comes from a drill rig, and a gamble measured in years and millions of dollars. Exploration is the most expensive form of gambling on Earth. Before a mine exists, a company must first prove that gold lies beneath a landscape that looks, from the surface, like everywhere else. It begins with geologists mapping rock formations, then geophysical surveys measuring magnetism and conductivity, then geochemical sampling of soil and stream sediment. These early stages might cost a few $1 million and reveal only a hint, an anomaly, a promising signature. Nothing is confirmed until the drill turns. Diamond drilling is the moment of truth. A rig punches holes hundreds or thousands of meters into the ground, pulling up cylindrical cores of rock that are logged, split, and assayed for gold content. A single deep hole can cost $100 to $300 per meter, meaning a 2,000-meter hole runs into the hundreds of thousands of dollars. And one hole proves almost nothing. To define a deposit, companies drill dozens, then hundreds of holes on a grid, mapping the gold in 3 dimensions. A serious drilling program routinely costs $20 to $50 million before a mine is even guaranteed. The odds are savage. Industry data suggests that of every 1,000 mineral prospects explored, only about 1 becomes a producing mine, roughly 1 in 1,000. The rest fail. Too low grade, too deep, too remote, too little gold. Years of work and tens of millions of dollars vanish into holes in the ground that lead nowhere. This is why exploration is funded largely by speculative capital, investors betting on odds worse than most casinos offer, hoping to catch the rare discovery that returns 100-fold. Even success is slow. From first anomaly to a confirmed resource estimate can take 5 to 10 years of continuous drilling and analysis. Only then can engineers begin a feasibility study, a document that decides whether the deposit is worth building. Junior companies routinely burn through all their money and dissolve, selling their claims to larger firms who can afford the next stage. And that next stage is not a shovel in the ground. Even with gold proven, confirmed, and measured, no rock can be moved until the government grants permission, a battle fought on paper that can outlast the drilling itself. Before a single haul truck moves, a mining company must climb a mountain made entirely of paper. Permitting is the phase that outsiders never see and insiders dread most, because it can consume a decade and cost more than all the drilling combined. The centerpiece is the environmental impact statement, a study that can run thousands of pages and take 3 to 5 years to complete. It must model how the mine will affect groundwater, air quality, wildlife, watersheds, and local communities, backed by baseline data collected over multiple years before anything is disturbed. In the United States, a major gold mine on federal land must satisfy the National Environmental Policy Act, the Clean Water Act, the Clean Air Act, and a stack of state regulations, each administered by a separate agency with its own timeline. Studies from the industry estimate that the average time from discovery to production in the U.S. now approaches 16 years, among the longest in the world, and much of that delay lives in the permitting gauntlet. Consultants, hydrologists, biologists, and lawyers must be paid throughout, whether or not approval ever comes. A single comprehensive permitting effort can cost tens of millions of dollars. Then come the public hearings. Local landowners, tribes with treaty rights, environmental organizations, and neighboring towns all have standing to object, and their objections can trigger litigation. A lawsuit can freeze a project for years, even after approval is granted. Some permits are challenged in court repeatedly, forcing revised studies and new comment periods. The mine sits idle, financing charges accumulate, and the deposit earns nothing. Companies must also post reclamation bonds up front, financial guarantees, sometimes hundreds of millions of dollars, held by the government to ensure the land will be cleaned up if the company walks away. That capital is locked before any gold is produced. Regulatory risk alone can kill an otherwise profitable deposit. If a jurisdiction is slow, unstable, or hostile, investors flee and the gold stays buried. Permitting is where dreams die quietly, not from geology, but from bureaucracy and time. Yet suppose every signature is obtained and every lawsuit survived. Now the true spending begins, because an approved deposit is still just a hole waiting for a machine that costs billions to build. A permitted deposit is not a mine. It is a construction project on the scale of a small city, and it must be built before a single ounce is sold. This is the capital cost, the money spent up front to create the entire mining machine, and for a major gold operation, it routinely reaches $1 to $5 billion. The first decision is how to reach the ore. Shallow, low-grade deposits are mined by open pit, enormous terrace craters, sometimes a kilometer wide and hundreds of meters deep, carved by blasting and excavation. Deep, high-grade deposits require underground mining, vertical shafts and kilometers of tunnels driven through solid rock, with ventilation, hoists, and ground support. Each approach demands a different, staggering set of machines. Consider the haul trucks. A single ultra-class mining truck, such as a Caterpillar 797, costs around $5 million, stands 2 stories tall, and burns hundreds of liters of diesel per shift. A large open pit needs a fleet of them, plus electric shovels and loaders costing millions each. Tires alone can run $40,000 apiece and take months to source. But the trucks only move rock. The gold must be extracted at a processing plant, the most expensive single structure on site. This facility houses crushers, grinding mills as large as houses, flotation tanks, leaching circuits, and refining equipment, all engineered to handle tens of thousands of tons of ore every day. A processing plant for a large mine can cost over $1 billion by itself. Then comes the infrastructure that makes any of it possible. Power lines or on-site generation to feed a plant that consumes as much electricity as a town, water supply and pipelines, roads capable of bearing 100-ton loads, tailings dams to store the waste slurry, worker camps, offices, and maintenance shops in often remote terrain. All of this is spent before the mine earns a single dollar. Companies borrow billions and pour concrete on the faith of a feasibility study, betting the deposit will repay them over 10 or 20 years. But even a finished, gleaming plant faces the hardest problem of all, actually tearing the gold out of the stone and losing part of it in the attempt. The ore arrives at the surface as nothing more than gray rock, and now begins the violent process of separating microscopic gold from the stone that has hidden it for 2 billion years. First comes the crusher, a steel jaw the size of a house, biting boulders into fist-sized fragments. Then the sag mill, a rotating drum 40 feet across, tumbling ore with steel balls until it becomes a fine slurry, ground to powder finer than beach sand. This grinding alone consumes staggering electricity, sometimes 40 kilowatt-hours per ton, and the mill must never stop turning. Once pulverized, the gold must be coaxed out chemically. At most large operations, the answer is cyanide, a dilute sodium cyanide solution, roughly 500 parts per million, dissolves gold from the crushed ore over hours or days in vast leaching tanks, or across heap leach pads the size of city blocks. The dissolved gold is then captured onto activated carbon, stripped, and finally smelted into a rough door bar, perhaps 80% gold, poured glowing into molds. But here is the cruelty of the numbers. Recovery is never total. A well-run mill might recover 90 to 95% of the gold in easy free-milling ore. In stubborn, refractory ores, where gold is locked inside sulfide minerals, recovery can collapse to 60% or less without expensive pre-treatment like roasting or pressure oxidation. That means for every ounce the geologists counted in the ground, 4 ounces may vanish. Multiply across millions of tons, and billions of dollars of gold is simply left behind, dissolved into tailings or trapped in minerals the process could not crack. The tailings themselves, a toxic gray sludge, must be pumped behind engineered dams that will stand for centuries. Every step, from crusher to smelter, is an exercise in loss, in energy poured into rock to extract a whisper of metal. The mine has now converted its buried ore into actual bars of gold. But the plant that made this possible never sleeps, and it never stops demanding to be fed with power, fuel, water, and labor. And those relentless costs are what truly decide who survives. Building the machine was the easy part. Feeding it is what breaks companies. Every single day the mine operates. It burns money on an industrial scale, and the largest hunger is energy. A big open-pit operation can consume as much electricity as a small city, and where grid power is absent, diesel generators fill the gap, swallowing hundreds of thousands of liters of fuel each week. When crude oil spikes, so does the cost of every ton moved. The haul trucks alone, each burning 50 to 100 gallons per hour, run 24 hours a day, 3 shifts, 365 days a year. Then there is water. Endless water for grinding, leaching, and dust control, often pumped from wells or reservoirs, and treated at heavy expense, especially in the deserts where many mines sit. Labor is the next relentless line. A modern mine employs hundreds to thousands of people: geologists, engineers, blast crews, metallurgists, electricians, safety officers, many flown in and out on fly-in fly-out rosters, housed and fed in remote camps. Wages, benefits, and camp logistics run into hundreds of millions annually. Add reagents, tons of cyanide, lime, and grinding balls, plus spare parts for machines that grind themselves to death. To capture all of this, the industry created a single brutal number: all-in sustaining cost, or AISC. It bundles operating costs, sustaining capital, royalties, and administration into one figure of dollars per ounce. In 2023, the global average AISC sat near $1,300 an ounce, but the range is vast. Efficient mines produce gold at $900. Struggling ones exceed $1,600. That single number is the line between life and death. If it costs you $400 to produce an ounce, you are merely counting how fast you lose money unless the market cooperates. AISC is why a mine with genuine gold in the ground can still bleed to death, why two mines side by side with identical ore can face opposite fates based on depth, hardness, and distance from power. The costs are fixed and relentless. Only one variable moves wildly, and it is entirely beyond the miner's control: the price the world will pay for gold. A gold miner controls the geology, the machinery, the payroll, and the chemistry. The one thing he cannot control is the only thing that matters most: the price. Gold trades on global markets every second, set in London and New York, driven by interest rates, inflation fears, central bank buying, and panic in distant economies. A miner who spent a decade and $2 billion building an operation is, in the end, a hostage to a number flashing on a screen. Consider the arithmetic. If your all-in sustaining cost is $1,300 an ounce, and gold sells at $1,900, you earn $600 of margin per ounce, and the mine is a fortune. But gold does not sit still. In 2011, it touched $1,900, then collapsed to below $1,100 by late 2015. Mines that were profitable in 2011 were underwater 4 years later, without changing a single thing about their ore or their machines. When the price falls beneath the cost line, the response is swift and painful. Marginal mines are placed on care and maintenance, a state of suspended animation where production stops but the pumps still run to keep pits from flooding. The 2013 to 2015 downturn shuttered dozens of operations worldwide and erased tens of thousands of jobs. Then, when gold climbed past $2,000 in 2020 and beyond, those same mines reopened, dusting off equipment, rehiring crews, chasing the very ore they had abandoned. This is why gold mining moves in brutal cycles, why a deposit can be economic one year and worthless the next, entirely independent of the rock itself. High-cost, low-grade mines live and die at the margin, breathing with every swing of the market. Companies hedge, locking in future prices, but hedging can trap them below a rising market too. There is no safe ground. The miner has poured everything into extracting metal from stone, only to hand its fate to forces oceans away. And yet even survival through the price cycles is not the end of the story. Because when the last profitable ounce is finally poured, the largest bill of all comes due. Every mine dies. The ore body that took 2 billion years to form is exhausted in 20, and when the last economic gram is pulled from the earth, the obligations do not end. They intensify. Closure is not the flick of a switch. It is a project as costly and complex as building the mine ever was. First comes reclamation, the legal and physical duty to return the land to something safe and stable. Open pits, some a mile wide and half a mile deep, cannot simply be filled. They are fenced, monitored, and often left to flood into acidic lakes that must be treated indefinitely. Waste rock piles and tailings dams, holding hundreds of millions of tons of toxic sludge, must be capped, contoured, and revegetated to prevent collapse and poisoning of rivers. The most dangerous legacy is acid mine drainage. When sulfide rock meets air and water, it generates sulfuric acid that leaches heavy metals for centuries. Some sites will require active water treatment forever, an eternal cost with no revenue behind it. This is why regulators demand reclamation bonds up front, sometimes hundreds of millions of dollars locked away before mining begins, insurance against a company that goes bankrupt and walks away. History is littered with abandoned mines where that money was never set aside, leaving taxpayers to inherit poisoned ground. So tally the true cost of gold: years of exploration betting on rock, a decade of permits, billions in construction, relentless energy, labor, and water, chemical losses in the mill, the whims of a price no miner controls, and finally, generations of cleanup after the profit is gone. The gleaming bar is the smallest, briefest moment in a story measured in decades and disaster. We began with a paradox, a mountain of ore that is worthless. Now we understand why. Wealth is not what lies buried. Wealth is what survives after every cost is paid. Between the deposit and the dividend stands a gauntlet that consumes most who attempt it. Remember this when you next see the price of gold, and hold in your mind the single truth this entire journey teaches. Gold and rock is not yet wealth.